Today, I'm here to speak about the basics behind the electrodeposition of stainless steel performed at EMPA laboratory in Thun in Switzerland. Electrodeposition is a fabrication process which consists of a liquid containing mainly the ions of the elements we want to deposit, in this case, iron, chromium, and nickel. The principle is similar to a battery, but here we are forcing a potential between the working electrode or cathode and the counter electrode or anode. In this way, we force first a reaction at the anode, which is called oxidation. Water is oxidized, losing electrons and forming oxygen bubbles. These electrons are attracted to the cathode, and there is a second reaction called reduction. The negatively charged electrode attracts the metal ions, which are reduced, forming the metal film. The case of electrodepositing stainless steel, however, is not so straightforward. We have three elements which have to be deposited with a typical composition around 18 weight% of chromium and 10 weight% of nickel in order to obtain stainless steel. In fact, chromium content has to be higher than 10.5 weight%. In this way, a passivation film is naturally formed and it gives the material the anti-corrosive features of stainless steel, typical of many commonly used objects such as pens, but also biomedical tools. To reach this desired composition, there are many parameters we can play with. For example, pH, temperature, etc. But the applied potential is the most simple and efficient way to tune the content of iron, chromium, and nickel. Electrodeposition is a cost-effective and versatile technique. We can deposit not only films, but micro and nano components as well. For creating micro components, a typical method is called Liga process, which consists of casting a resist on top of a conductive substrate, using a lithographic tool irradiating the resist with a mask of the chosen design, then developing the resist, obtaining the desired molds. The next step is electroplating inside the mold. Here, the main difficulties are linked to non-uniform current distribution and low ions concentration at the electrode surface. And finally, removing the resist, the desired microcomponents is achieved.